if we want to do calculus with parametric equations, we need the two formulas. dy dx, slope of the tangent line, is dy dt divided by dx dt, as long as the derivative of the bottom is 0. And the concavity, or the second derivative, d2y dx2, is the derivative of dy dx, or the derivative of dy dx divided by the derivative of x with respect to t. Okay, so we're going to use those two formulas to answer the following question. A curve C is defined by the parametric equation x equals t squared, y equals t cubed minus 3t. And we want to look at the tangent at 3, 0 and find the equations of those tangent lines. So I guess the first question would be, why does it have two tangents at this point? And we can see that by taking a look at the y. Notice y equals t times t squared minus 3. So what we're saying here is that y is equal to 0, and what we have is this is going to work out if y equals 0, if t equals 0, or t equals plus or minus the square root of 3. And if we substitute those back in for x, then x equals 0 when t equals 0, so we don't want that point. And if we substitute the other one back in for x equals t squared, we get positive 3. So that gives us our 2 points when t is plus or minus square root of 3. Alright, so we want to find the equations of the tangent line, so we need to know the slope of the tangent line. That is, we want to know what dy dx is. In order to find dy dx, we should find dy dt. dy dt is 3t squared minus 3. And we need to know what dx dt is. dx dt is 2t. So, using the formula above, dy dx equals dy dt over dx dt. We have 3t squared minus 3 divided by 2t gives us our slope, and then we want to know what's the slope when t is plus or minus square root of 3. Once we have the slope, we can go ahead and use point slope form of a line to find the equations of the tangent lines. Okay, so you can fill in those details. Part B, find the points on C where the tangent is horizontal or vertical. So to find where the tangent is horizontal or vertical, we are looking at dy dx, which equals 3t squared minus 3 over 2t, and we are setting this equal to 0, and we want to know when it is undefined as well. So if we set the top equal to 0, that would be the horizontal tangent lines, So t cubed minus 3 equals 0. I prefer the factoring method as opposed to the solving for t method, but you can do whatever you want. And you see that when t is plus or minus 1, we have our horizontal tangents. In order to find our vertical tangent, that is when is 2t equal to 0, then t equals 0. So that gives us part B. Part C asks whether or not the curve is concave up or concave down. In order to determine that, we need the second derivative. So the second derivative is dt dy dt. Oh, sorry, that's dy dx divided by dx dt. Okay, so we're going to take the derivative of dy dx and then divide it by dx dt. So the derivative of dy dx with respect to t. What was our dy dx? That was up here. So we need that derivative, and then we need to divide it by the derivative of x with respect to t. So I think the easiest way to find this, we could use the quotient rule to do this, or we could just say 3/2 t minus 3/2 t to the negative 1 and use that. That's probably the easier derivative. So the derivative of that with respect to t is 3/2 plus 3/2 t to the negative 2. Then the derivative of x with respect to t was 2t. So here we have the second derivative. If we want, we can simplify that, but sure, let's do it. So let's factor out 3/2 up top. So we have 1 plus t to the negative 2 all over 2t. And what we can see from this, if you want, we can factor out a t to the negative 2. And we get t to the negative 2 times 3/2 parentheses t squared plus 1. Another way to say what we just did was that we got a common denominator there. And this, if you do a little bit of algebra, we have 3t squared plus 1 over 4t cubed. Because the 2 and the 2 multiply together give us 4. We bring the t to the negative 2 down to the denominator and combine it with the other t's to get a t cubed. So the only place that this can change from positive to negative is if the denominator is positive or negative, because the numerator is always positive or negative. I'm sorry, the numerator is always positive because you take a positive number squared, add 1, it's still positive, multiply 3, it's still positive. So if we want to do what we did in Cal 1, here's when t equals 0, and this is our second derivative, d squared y over dx squared. Then to the left of 0, the numerator is positive, the denominator is negative, means we have concave down. Over to the right of 0, a positive number cubed is positive times 4 is positive, the top is positive, it's still positive, and it's concave up. Alright, so there you have it.